we look at the solutions to problem set 19 here, which are on probability. What is the probability of winning the lotto? Now we've done the Euro Millions, and it's basically the same maths. Here we pick 6 numbers from 1 to 47 and 1 bonus number. So a 7th one from 1 to 47. There are no lucky stars in the lotto. So we only have one pot, picking 6 numbers from 1 to 47 without replacement. As in, you can't draw the same number twice. So how many ways can we do this? Well, the first number can be any one of 47, the second any one of 46, and so on, leading to 47 times 46 times 45 times 44 times 43 times 42 possibilities. The order doesn't matter, so we divide by 6 factorial. This is also known as 47 choose 6, and written as 47 and 6 in a bracket, which is equal to 10,737,573. And you can just type in 47 choose 6 into Google and it'll work that out for you. So the probability is 1 over 10,737,573. And you can also check this by typing into Google probability winning lotto jackpot, and there are pages where they work it out for you and they get the same answer. We roll 3 10-sided dice and add what we get. What are we most likely to get? Well, we can get 30 and 3 only one way. So if we roll 10 3 times, that's 30, but that's the only way that we can get 30. But other numbers you can get multiple ways, and so the probability of getting those sums is greater. I'd guess 15, which is halfway, occurs the most, because if you have 30 being the highest number which you can only get one way, and 3 being the lowest number that you can only get one way, and that it kind of increases as you get closer to the middle. But I couldn't find a quick and easy way to actually work out what the answer was, aside from actually doing all the 1,000 different possible things you can do and just counting which occurs most often. So looking in Google, found that we can get 13 and 14 in 75 different ways, while 15 in 73 different ways. So the answer is 13 and 14. But it's a far harder question than I thought when I wrote it. We toss a coin 5 times. What is the probability that we get 4 heads and 1 tail? Well, there are 32 possible outcomes. We can get 4 heads and 1 tails in 5 ways, since the tail can be the first, second, third, fourth, or 5th toss. So the probability is 5 over 32. We have a bag with 5 green balls and 2 red. We pick 3 balls. What is the probability that we end up with 2 green and 1 red. To end up with 2 green and 1 red, we could pick red, green, 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 red, green, or green, green, red. And this is without replacement. So we begin with 5 green and 2 red in the bag. So the probability of getting red, of picking a red as our first ball, is 2/7, since there are 2 red balls out of the 7 possible. Then we have 6 balls left in the bag, 5 green and 1 red, since we've picked 1 red out of it. So the probability of getting a green is 5/6, since there are 5 green balls and 6 balls in total. Now we have 5 balls in the bag, 4 green and 1 red. So the probability of picking a green is 4/5, since there are 4 green balls out of a total of 5 balls. To get red, green, green, we multiply them, since we need to pick a red from our first one and a green for the second and a green. And when we have and multiple things that need to happen at the same time, we multiply. So that's 2/7 times 5/6 times 4/5. So just to simplify, we just cancel the 5s and end up with 2 times 4, which is equal to 8 on top, and 7 times 6 equals 42 below. Divide top and bottom by 2 and we get 4/21. For green, red, green, we'd do the same process, and we get 5/7 times 2/6 times 4/5, which simplifies to 4/21 again. Finally, for green, green, red, we also get 4/21. Here we could have red, green, green, or green, red, green, or green, green, red. So we add the probabilities to get 4/7. So this is one of the trickiest questions that you might be asked. Evaluate 6 choose 3. Well, that just means 6 times 5 times 4 divided by 1 times 2 times 3. So we have a 6 below and we have 6 above, cancel those, so we end up with 20. We can also write this as 6 factorial over 3 factorial times 3 factorial. That's just a shortcut, so that instead of writing 6, 5, 4, which is writing 3 numbers, we just write 6 factorial over 3 factorial, since that removes the times 3 times 2 times 1, which we get when we write 6 factorial. We pick 3 cards from a pack. What is the probability that we end up with a 3 of a kind? So 777, 888, or something like that. But like with the pair question, we're going to start with a card, doesn't matter what. Now there are 51 cards left, but only 3 match the first card. To get a 3 of a kind, we need to pick one of those 3. The third card also has to match, so we need to pick one of the 2 remaining from the 50 cards left. We need the second and third card to match, so we multiply the probabilities to get 3/51 times 2/50. which works out at 6 over 2550, which is 0.002359, and so on. Remember to subscribe to be updated when new content is added. Thanks.